Here, the secondary water treatment system is being placed in operation. Sulfite and phosphate mixed with condensate are added to the feed water at the HTA package. At the console, the coolant charging pump suction solenoid valve may be switched to condensate if within limits. The next scene shows some of the plant parameters during normal operation. During his watch, each equipment operator records hourly readings of plant indicator gauges. A maintenance check of the turbine lube oil filter. This is done during each watch. Checking the air ejector non-condensable gas discharge flow rate. This is done frequently to detect any air in leakage to the exhaust system. Another routine check, using the console temperature scan system to detect any abnormal operating condition. A recorder continually monitors the primary building for any increase in airborne activity. Although it has built-in alarm systems, it is continually monitored by the equipment operator. When either of the hold-up tanks is filled, the operator transfers the water to the radioactive waste disposal system for processing. Water taken from the radioactive waste disposal system evaporator overhead is sampled for radioactivity analysis. If radioactivity and chemical purity are within acceptable limits, the water may be reused by transferring to the condensate storage tank or directly to the shield water system. Unsuitable water, if within limits for discharge to the environment, may be discharged overboard. If not within limits, it must be reprocessed before discharge. When the plant water supply, held in the condensate storage tank, needs replenishment, the secondary evaporator is put into operation. The system is checked for a proper valve lineup. The evaporator feed pump is turned on. This takes water from the potable water tank and the snow melter. turn on auxiliary steam. And vent the overhead to the atmosphere. Establish blowdown on the evaporator. Check the water for conductivity and chemistry. Finally, if water is within limits, valve the overhead to the turbine exhaust system. A routine duty for the control room operator, taking hourly readings of console indicators and area radiation monitors. This operator has just left the primary building. After removing protective clothing, he stops at the hand and foot counter to check for spreadable contamination. Health physics personnel continually monitor the plant for radioactivity. This man is seen using a portable radiation monitor. After each 2,500 hours of operation, the plant is shut down for testing. When shutting down for this or for any other maintenance, inform the base electric shop so they can start base diesel generators and assume the base load. Reduce the plant load. Start the plant emergency diesel and assume the plant load. Then rapidly secure condenser fans, close the superheater steam flow controller, close main steam stop, trip turbine throttle, open generator and exciter breaker, close condenser louvers, manually maintain level in the HTA package and the level in the steam generator. To shut down the reactor, with rod selector switch in the all position and speed selector in slow, operate rod motion control switch to the in position. Adjust individual rods to maintain rod position within 1/2 inch of each other. Should a low pressure annunciator alarm be received, place the low pressure scram bypass switch in bypass to continue with an orderly shutdown. Continue inserting rods until the position indicators are at 2 1/2 inches. Press the scram button. Now place the primary coolant pump bypass switch in the bypass position to reset scram. Turn on the primary coolant pump and return the bypass switch to normal. The rate for reducing primary loop temperature must not exceed 100 degrees per hour. This film report has shown some of the procedures for starting, operating, and shutting down the PM3A Navy nuclear power plant. For complete and detailed instructions, refer to volumes 1 and 2 of the operating manual.